In this video, I wanted to compare some different types of equations, different forms of equations that you're going to see. So what I did is I wrote all the standard equations of the conics on this side, and over here we have standard form of polynomials on this side. I want to start with the conics here because I want to draw a comparison for you, and then we're gonna compare this to the polynomials on the other side. Okay, so here are our four conic sections, or the four shapes that are in the family conic sections, right? The circle, the parabola, the ellipse, and the hyperbola. And these are the standard equations for those shapes. What we've done so far is we've talked about circles and we've talked about parabolas. Okay? There's two more in here that in this family that you're going to learn again in another class. They're the ellipse and the hyperbola. But I wanted to take a look at all these equations and just so you can compare them and you can see what they have in common. So this is the circle. We just talked about this in the last video as like a review. You got this x minus h piece, the y minus k piece, and then you have your r. Okay? Now if you compare all of these equations together, just kind of give them a glance, you'll notice that they all have some really similar pieces, right? Like this has an x minus h squared as well. And it also has a y minus k. Or if it's a sideways parabola, we have a y minus k squared and an x minus h. So kind of similar things going on. Here we have an ellipse. This is the equation for ellipse. Again, you have those same kind of pieces as you do in your circle. You just have some like dividers. An ellipse is basically a circle that's like stretched or elongated. It's like an oval shape. So that's why these equations look so similar to each other. If you take an ellipse and you kind of like make the height smaller than the width, it's going to be kind of an oblong shape. And then you have a hyperbola. And let me just give you a quick sketch of each of these. Circles, of course, look like this. We know that. Parabolas can open up, down, or left or right. An ellipse is kind of like an oval. And then a hyperbola, it kind of looks like a parabola, but there's two pieces to it at the same time. So something like that. But all those equations look very similar. Okay? Now we're going to focus on these two, but I just wanted to show you that there are, the equations for the ellipse and hyperbola have similar structure, similar pieces. Okay. In the previous example, we talked about how to get an equation into this form, into this what we call standard form, or find the standard equation of a circle. In the next video that we're going to do that for parabolas. I'm going to give you an equation for a parabola that's kind of all messed up, and we're going to have to like use complete the square to get it into this form. Okay. Let's take a look at the other side here. Standard form of polynomials. Now this is a completely different family. These guys don't have a whole lot to do with each other. Here we can see a degree 1 polynomial. That's like a linear equation. A lot of times we use an m for this, but the idea is that we have the x term first and the constant term second. This is a degree 2 polynomial, or what we like to call a quadratic. Right? And this is the standard form of a quadratic equation, right? ax squared plus bx plus c. Okay? A degree 3 polynomial standard form would be ax to the third plus bx squared plus cx plus d. So the pattern is you always put your highest power of x first, and then you call the coefficients a, b, c, just go down the alphabet. Okay? So this is how you write a polynomial in standard form. The reason I bring that up, though, is because we have kind of a terminology issue here that we are butting up against. Because what is the graph of a degree 2, a quadratic? It's a parabola. You see where this could maybe start to get confusing? We're saying standard form of a polynomial of degree 2 is this, but the standard form or standard equation for a parabola is this, but we know this is a parabola as well. So this word standard gets thrown around a lot, and we're like, what does it mean? And different books will call these forms different things to kind of get around that terminology issue. Sometimes these are called general forms instead of standard forms. So there's just different terminology. We've got to be careful with the terminology, and I want to just make sure that you guys know what I'm talking about. Because of this issue with calling multiple things standard, what we did is we decided to call this form of the parabola focal form. Okay, just to avoid all that mess, all that confusion. We called it focal form because this has the focal width, right? 4p, if you recall, is the focal width of the parabola. And of course, we talked about how this could be negative if it's going to open down. So that we're going to call focal form. And over here, we decided to call this guy right here quadratic form, because it's confusing to call them both standard form, or say this is standard form and this is a standard equation. That's kind of tricky. So basically what you have here is you have, if you think about it, like a Venn diagram, right? And over here we have conics, and over here on this side we have polynomials. And what's in the overlap? What's in the overlap is your parabolas, right? Because a parabola is a graph of a polynomial degree 2, but it's also in the conic family. So quadratic slash parabola is the intersection of these two families. So we've talked about quadratics from this perspective. We've talked about graphing parabolas and transforming parabolas from this polynomial perspective, right? It's just a polynomial of degree 2. Okay, now we're kind of shifting over to this family. We're talking about parabolas in the same context that we're talking about circles and ellipses and hyperbolas. We're talking about it as a part of this family, which is why the equation looks a little bit different. It looks more similar to something like this or this or this. So there's two different families, there's two different perspectives. The thing about parabolas over here that you can't have over here is here we're talking about functions, right? Polynomial functions. So over here you couldn't have something like this. You couldn't have a parabola that opens sideways because it wouldn't pass the vertical line test. It wouldn't be a function. But over here, these are not functions, right? These don't pass the vertical line test in most cases. This parabola will, but the sideways parabolas won't. But that's okay because these aren't necessarily functions. They're just equations. So that's a little bit of the difference behind the standard equation for conics and the standard form for polynomials. And again, to get around that, we're going to use focal form and we're going to use quadratic form. Now for circles, we'll still probably call this the standard equation because there's only one form of circles that we really have to deal with. There's only one equation that we have for circles. I hope that clarifies a little bit of the terminology, or at least gives you a peek behind the curtain on why this terminology can be confusing, and helps you keep kind of separate the ideas of polynomials and conic sections. In the next video, we're going to talk about how to take equations and put them in this form using complete the square. So stay tuned for that.